Okay. Sorry, I just skipped through the whole thing. Okay, so I think it's often good here to like step back and basically think, like what are the long-term goals of, or at least even like medium-term goals of Ethereum user experience here, right? So I think. Ideal Ethereum user experience is obviously just like have some kind of BCI and you think about what you want to do and then like that just immediately happens on chain, but that's going to take a while. And so let's like think about things that are actually like short term achievable, and especially in the context of like some of the newer technologies that we're seeing, right? So I think one of the big topics, right, is basically that Ethereum today basically looks like a bunch of different blockchains. And this is a screenshot depositing to Polymarket that I often use, right? And basically, the challenge here, right, is that Polymarket is an application on Polygon. It uses USDC on Polygon. And if you have your coins somewhere not on Polygon, then you have to use this like special operation called bridging to actually move the coins over, right? And so Polymarket here has this like fairly complicated deposit flow, and like it says, hey, important, select Polygon as the network, not Polygon ZK EVM. That's totally different. And if you get any of this wrong, you lose your funds. Like I actually personally lost $100 on this. So right now it's like not great, right? And what we want out of Ethereum tomorrow is like a unified ecosystem. We want something where like an address actually is something that tells you that like tells you where money is going. You want something where sending from one L2 to another L2 feels like the same type of operation as doing something within a single L2. You want an ecosystem where all of this happens maximally quickly, maximally cheaply, maximally trustlessly, and through open standards without any centralized dependencies, right? So this is all like a pretty big challenge, right? And I think there's obviously a lot of work like happening on this, but it's also something that's becoming part of the account abstraction space as well, right? Because if you're a wallet, then like even today you have to think explicitly about the cross L2 question, and the cross L2 issue is like a first-class citizen as a problem, right? And so if you think about like supporting key changes or upgrades, you have to also think about supporting upgrades across different layer 2s. So another problem that we have is, of course, wallets, right? And wallets, I think we basically, so historically, we've had this like very annoying kind of dichotomy, right, between two types of wallets. So one type of wallet is basically you have your own private key. You have your own seed phrase. If you want even more security, you put the seed phrase into a titanium lockbox and it's fireproof, and it goes all the way up to 3,420 degrees. No, wait, sorry, that's tungsten. Wrong T. Some high number of degrees, and you put the whole thing like 19 feet underground. Oh wait, sorry, we're not in the US. 19 meters underground. And like you have maximum security, right? And like this is the kind of approach that some people are like try to advocate, right? And then obviously there's a lot of people that just say like, no, screw you to this. And so realistically, what do they end up doing? They end up going the other direction and saying basically like, hey, I can't do this security thing, like at least like through self-custody. And so I'm just going to take all my coins and I'm going to put it all up on some centralized exchange. Look, it's run by this guy. Look, he looks trustworthy. He like donates to nice charities. He goes on panels with Bill Clinton. Like very trustworthy guy. And then of course, 2 years later, you find out that he's like actually not so trustworthy, right? And so you have this like dichotomy, right, where like wallets are either good at protecting you from centralized bad actors, but do nothing to protect you from your own mistakes. And then there's wallets that are good at protecting you from your own mistakes, but they might actually be the centralized bad actors. And so there is this like desire to try to make smart wallets that basically give you close to the best of both worlds, right? And I think that is exactly where Ethereum is going. That is definitely not where like classical Ethereum wallets are, right? Basically, you have this choice between like seed phrases, custom hardware wallets, multi-sigs that are relatively complicated to set up, And like that's improving over time, right? Like one thing that exists now that did not exist years ago is just like the ability to plug in a safe into a wallet, right? Like at least Rabby supports this, other wallets support this, and like just like actually use it as your normal wallet. But these are still things that need to continue to improve, and then you need to figure out like what actually is the access control mechanism if it's not a 12-word seed phrase and if it's not like the centralized exchange's 12-word seed phrase. So what is the ultimate goal, right? I think to me in Ethereum, right, I mean, I think like North Stars are kind of cringe, and so let's like talk about the bright star. So so what is the like thing that we are trying to do, right? Basically, I think there's a lot of people who are sacrificing decentralization for practicality, and then there's a lot of people who are sacrificing practicality for decentralization. And our goal is basically that we do neither of those sacrifices, and we take both and we get both, and we manage to get both because we've made all of these amazing advances in technology that allow us to actually do that, right? So I think this is like the ultimate goal, right? And I think we always want to like start from understanding. So this is the goal, and in each specific context, how do we actually try to achieve those things? So there's like a bunch of things that we want to fix, right? So one is bridging should not be a separate operation from sending, at least definitely not from the user's perspective. I think eventually even in the protocol, like there should be some kind of native cross layer 2 sending, or at least as an ERC. So bridging and sending should appear as something identical, right? All you're doing is you're just sending assets from Ethereum to Ethereum, right? Optimism is Ethereum, Arbitrum is Ethereum, sending assets from Optimism to Arbitrum is sending assets from Ethereum to Ethereum, and it should look to users like that's what's going on. There's like short-term UX problems, so the need to do approvals. So if you want to swap tokens, having to send 2 transactions, that's a UX concern. It also ends up being a security concern because people end up approving infinity to just like avoid having to deal with this issue, and then they get like hacked for a lot more than they should. And also building applications to be friendly to both new users who don't yet have a crypto wallet and experienced users who I think ideally don't want to have to manage like 100 different wallets with 100 different backup keys and would want everything tied to like some single thing that they can trust. Also, quantum safety, right? So ECDSA, which EOAs run on, is going to die to quantum computers, and a lot of people are expecting that'll happen within like 10 or 20 years. And potentially other security goals, wanting to stick keys inside of trusted hardware chips that maybe don't support SEC P256K1, which is what EOAs run on, but do support SEC P256R1, maybe ED25519, maybe other fancy cryptography too, right? So there's like a list of like a whole bunch of little problems that we want to solve. And I think in a lot of these cases, what we see is like there is a hard way to do it that already works, and then there is a centralized way to do it that already works. And like what we want is we want like the decentralized way that's not hard, right? So cross-chain transfers, so this is one of those topics, right? So I think there's a lot of discussion about just like migrating the address format, and so this is like one of those possible formats, right? Basically chain at address.eth. Like basically the principle is that an address should contain not just like the address 20 that says where you are within a chain, but also like which chain you are. And from a perspective that lets you identify Ethereum L1, also L2s, also L3s, like potentially the entire hierarchy. And then you can take this and you should be able to just put this into a wallet. And if you put it into a wallet and you don't yet have coins on that chain, the wallet should just like figure out some way to get coins over onto that chain for you, and to you it still should just look like a button click, right? Technology for doing this exists, across exists, and is like actually, like building on 7683, you can move from Optimism to Arbitrum in 2 seconds, at least for like reasonably small values. So it's starting to happen. So I think short-term bridging is like intent-based, basically, rely on liquidity providers, and then longer-term bridging, I think there is a path to try to have direct message passing work for at least a lot of use cases. I think even if we have direct message passing between L2 standardized, we could easily see a lot of users still using intent-based stuff, basically because anything direct message stuff has to go through L1, minimum 12-second time, and a lot of the time people will want speeds that are faster than 12 seconds. But then on the other hand, if you're moving like very rare assets or if you're moving NFTs, then like you can't front liquidity for an NFT because you don't even have like multiple copies of that NFT. So that's like one of those areas that's just important from a UX perspective. Now, if we want to like get back into the whole question of like abstracting authority and like signing, right? So EIP 7702, we just heard a bunch about it. It's the next big thing in the account abstraction space. And I think it's worth going through like what it solves and what it does not solve, right? So I think of account abstraction as being split between what I call convenience goals and security goals, right? And then, like, there's different ways of trying to split this, right? So you'll have likes talking about abstracting everything, and then you have validation, execution, gas payments, and like a couple of other conditions. But in the security and convenience framing, basically, 7702 solves like all of the most of the convenience stuff, and it also, but it cannot solve most of the security stuff, right? It solves a little bit, like you could do account recovery with it, kind of, but there's still a lot of stuff that it does not solve, right? And so for me, 7702 is nice because it's this like very nice forward compatible foot in the door. You basically have the convenience features of smart wallets become available to EOAs in a way where the code paths that are used to do that are basically the same as the code paths that get used in smart wallets, and then wallets can become smarter over time, and then we can do like more future things over time to actually also satisfy the security goals. So there's also potentially discussion around like native account abstraction and EIP 7701. Somehow it comes right before 7702. I mean, maybe that's a sign. Maybe it should come in the fork right after if we work really hard. But basically, like on top of EOF, abstracting out just like the validation part and trying to make abstracted validation work in a way that's really nice and clean as well. So that building out the wallet garden ecosystem. This is one of those things that I think is an important like practical projects to really try to work on, right? Basically, guardians are like here we're just talking about what is the thing that a user ultimately trusts, right? And information, theoretically, it's obvious that the correct answer is some kind of diverse multisig, right? Like you don't want to rely on one thing, you want to rely on multiple things where the reasons why each of those different things might fail are completely uncorrelated with each other, and so that way you minimize the risk of like some kind of crazy simultaneous failure. So that's like the ideal, right? And it's like kind of mathematically provable that that's the ideal. Like if you make a model and you say, here are different things that represent my authority and they have some probability of like either doing the wrong thing or just not doing the right thing anymore, right? So like if you have a third party and they get hacked, or if you have your own seed phrase and you lose it, and you try to figure out like what is the optimal way to have minimum probability of like losing access to your funds, like it's basically a diverse multisig, right? Now, the challenge is like, how do we make the UX of doing this actually friendly, right? And so I think in order to like more easily find the answer to the question, like what I want to see is an ecosystem that's like a very standardized ecosystem of these different Guardian components that just becomes very easy for people to recombine in different ways, right? So one of the ways I think about it is the Unix philosophy, I mean a long time philosophy of how things like Linux and all these Unix-like based operating systems basically text as the universal interface for data. And Ethereum philosophy, I think, is ETH addresses as the universal interface for authority, right? And so what I mean by this is, I think the most interesting examples are basically in this category where you go down to institutional guardians and you go to ZK wrappers of existing services, but really it's like any of these categories, right? So ZK email, you take an email and you're able to convert that email into an Ethereum address that represents that email address's authority, right? With ZK email, you can make a smart contract that you can only send transactions through it if you provide a proof of a DKIM signature from an email account, and then you just make a counterfactual address that just has that smart contract code, and you have a 20-byte address that can only be spent by someone who has that email. Then a knotted HAR, ZK passport, ZK Mina card, blah, 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 blah. I'm sure people have heard of like 10 of these. Those are basically ways to make an ETH address that represents like one of these many different forms of government ID. TLS notary, basically a pretty general purpose package that with some trust trade-offs that can do a similar thing for Web 2. Like basically, ETH addresses can stand in as this universal interface for these like signals that make their own different attempts of like representing your identity and like being a thing that only you can control, right? And so the more of an ecosystem of those we can have, and I think this includes ZK wrappers of existing services. This includes companies deliberately being specialized guardians. I think historically this did not happen just because there's not enough demand for it to happen by itself, and so there's not enough reason for a company to actually do this service. Friends and family, so if someone already has an Ethereum account, you can use them. Also your own devices, so basically hardware wallets, and then like a passkey is a hardware wallet. Lots of things can be hardware wallets. And you have all three of these different types, right? And potentially, like you can combine the two. Like you can have a ZK email to verify your friend's email. So there's like a lot of different options, right? And so the ideal world that I want to see is like, here's like a mock-up. Like basically imagine you have like a Gnosis safe that just has ZK email integration, right? And so how would this future world look like? It would look like a world where you're setting up a multi-sig account and you're specifying a list of guardians, and you have like your ETH address over here, and then also you can just like put an email address as a signer, and then in the back end it just automatically converts that into an Ethereum address, and then you could just like add it just like that, one click, and it works, right? So this to me is like the ideal that we want to try to move as fast as possible to trying to work towards, right? And I think the technology pieces are basically there. They need to just be put together, right? And if we get all of that, then I think we can start getting towards some kind of ideal wallet, right? So, I mean, to me, what does an ideal wallet look like, right? What would something look like where I would be comfortable using it for payments, and I would be comfortable using it to store my life savings, and I would be comfortable recommending that wallet to non-technical people and to experienced technical people and to people with all kinds of threat models. So for me, one key principle is that you want to separate low-risk and high-risk tasks, right? So for low-risk tasks, you basically just want to have a key on device, right? So just like, if all you want to do is like send someone $25, you just have a key on device. If you want to take it inside a TPM, because that has no extra cost, and then you just like click and you send the transaction. But then for anything high level, like sending off like $100,000 or recovering the key that's doing the low risk things, then you want something more complicated, like realistically some combination of guardians, right? And so then the question is like, what is the more complicated thing, right? And I think the more complicated thing is different for different people, right? Like ideally we want a framework, at least like at a high level, something that allows people who are different users, who have different trade-offs, who have different levels of experience with the ecosystem, to use different things, right? And I think like different people are going to have different things that they're comfortable with, right? For a new user, what you probably want to start them off with is just a ZK email wrapper around their existing email. The probability that their email somehow gets lost or gets hacked or breaks, or like the email server gets hacked, is realistically less than the probability that they on their own will just screw up and like forget to move their key over when they upgrade their device or like lose it or something, right? For a more experienced user, a lot of people are opinionated about like what things they trust, right? Some people only trust their 12-word seed phrase. Some people would only trust a hardware wallet. Some people would trust something else. Some people might want to upgrade to being quantum resistant ahead of time. If you want the social recovery approach of like trusting friends and family as guardians, then if your friends and family are crypto people, you can ask for their ETH addresses. But for a lot of people, like they don't have friends and family that have ETH addresses, and so instead you could actually use their emails. And so there's like different trade-offs to work for different people. And I think what we don't want to do is we don't want to like force people into a category that's not comfortable for them, right? You don't want to like force new users to go and download a fully fledged decentralized wallet and tell them that like that's the only way to use Ethereum. And at the same time, we don't want to create applications that like force you to use a Google account when if you're an experienced crypto user, like you don't want your Google account to be your root of trust. You want like your ETH address to be your root of trust where you have a multisig that you figured out and like you already trust it, right? And you want like one common framework that's able to accommodate both. So I think we have the technology to actually do this. We have the technology to actually make every wallet have an advanced option where you can set what your guardians are and then just like choose whichever guardians you want. So I think we have technologies to do a lot of these things, right? So I think some other considerations that matter here are, so one is, as I mentioned, cross-chain accounts, key store wallets. Basically, wallets are going to exist everywhere. And step one is if you have key changes, you make them replayable. And then step two is this key store wallet concept where the keys actually live in one place that can be read from anywhere. So for that to work, L2s need to implement some kind of like L1 load or L1 static call, like that sort of functionality. But this is one of those things to think about. Privacy is important to think about. So for privacy, I think the delegatable framework, so like some of Dan Finlay's work around making it easier to have like lots of wallets and one wallet per application, like that's actually good because that's nicely forward compatible with using more privacy preserving means to like sense the self between your different wallets. And so if you do that, then like we actually start like reducing some of the on-chain information that like just gets broadcasted and gets viewable to everyone. And privacy also does have some account abstraction related considerations as well, right? So especially for cross-chain accounts, like you don't necessarily want to like actually link them all to each other. There are ways to create an account that can generate an unlimited number of stealth addresses that are all unlinked to each other, but that are still controlled by the same keys that automatically update with one single transaction, right? And that's like the zero knowledge proof based key store approach, right? But that actually takes more infrastructure and more resources to actually build. ENS also, so with smart accounts, you might end up having different addresses on different chains, and this is like kind of avoidable, but then there might be edge case chains where it's not. And so when it is, you want to be able to have your address on lots of different chains be available at ENS. So there's a lot of these different like infrastructure considerations that need to be done, right? So I think in general, like the conclusion is, right, that like we have a lot of this powerful technology. And I think if we think back to the ultimate goal, which is we want decentralization and we want convenience at the same time in a way that works for all kinds of users, then we do have all of the ingredients that we need to actually create a really flexible framework that actually accomplishes this, right? And account abstraction is part of it, like actually building these ZK wrappers is part of it, actually building and improving the underlying wallets is part of it. There's a lot of infrastructure that we can use, and I hope that we can keep building this. Thank you. Okay.